everyone, today we are going to talk about our basics of our polar graphs and our plotting of their coordinates. So a polar graph is a different type of graph that we can plot on. So we are very used to our Cartesian graphs, kind of our x comma y, plot the points on the appropriate axis. We do this quite a bit in our mathematical careers. We also have, though, a different type of graph, which is called a polar grid. And these are basically made up from concentric circles and rays that are around the common center point. So we have a pole, which is the origin, 0, 0 basically, on the polar coordinate system. And then our polar axis, we kind of start over here at 0, whether that be in radians or degrees. It's kind of like the positive x-axis if you want to think of it that way. So then each part that we go out, that is your r or your radius or radial coordinate, and again that's your distance from the center, and the angle measure in which you're rotating around is going to be dictated by this theta measure, whether it be in degrees or radians. And again, going counterclockwise is our positive direction, if you want to think of it that way, or if we go a negative theta value, then it would be going clockwise. Okay, so it kind of works the same way. So as we have talked about a lot over the past semester, we know again that the positive is going up, negative is going down, and that there's multiple representations possible. For instance, these theta values, you're going to end up at that same location if you add or subtract 360 or 2 pi n. Or if we deal with a negative r value, what could also be true is basically a negative r value would move it 180 degrees, kind of flip it across the r value. So sometimes you could change it back to being positive by adding or subtracting 180 degrees, making it a positive r value, or again, pi if you were dealing with radians. So the main difference that we see here is that with our normal xy coordinates, there's only one way we can represent something, x comma y, but some of these points can be represented in multiple ways, really an infinite amount of ways, because of being able to find coterminals or that negative r value. So we see again an example of that, like if you're at negative 3, 5 pi over 4, instead of graphing over here, that negative r sends it back 180 degrees or pi radians. So for each of these following examples, we want to actually find our different ways to represent each of these following points. So for the first one, if you think about just adding or subtracting 360 degrees, two other ways we could write this is if we add 360, we could make it 2 comma 500, which would be 360 plus 140, or we would have 2 comma negative 220 if we subtracted away 360 degrees. Another way that we could write this is if we change this r value to be negative 2, then what could happen is you could add or subtract 180 degrees. So if we made this a negative 2, we could say, okay, 140 plus 180 would also work, or 140 minus 180 would work. And again, in each case, we would make that r value then negative. So negative 2, 320 would be a location, or negative 2, negative 40. Same idea with radians. Again, you can add or subtract 2 pi, and that's going to give us some of the values that are again kind of coterminal, would be in the same spot. So if we add 2 pi to 1 pi over 4, again in our calculators we often don't put that pi button, we just would say plus 2 or minus 2. So 9 pi over 4 and negative 7 pi over 4 would be two potentials for these values. And again, if we switch this to being a negative r value, okay, you can add or subtract 1 pi. So if we made this a negative 5, we could take pi over 4 and add 1 pi to it. We'd be at 5 pi over 4. Or if we subtracted 1 pi from it, we'd be at negative 3 pi over 4. So these could also then end up working as basically equivalent values that would land us at that same point. All right, on the next page, we have some examples then with actually plotting these points. So if we're in degrees here and we are at 2,60, we're going to go 2 units out from our center pole, and we would be at 2 radii out on 60. That's point A. Point B, it might be to our advantage so that we don't get confused with the negative. If you are going to change this R to be a positive 4, remember then we're going to add or subtract. In this case, I'm going to add 180 to 150 so that I really see this is the same location as being at 4,330. Right, these are equivalent. And to me, I like dealing with that positive R value because then I just know, okay, I'm at 330 degrees and I'm 1, 2, 3, 4 units out. This is my point B. 5, negative 45, you could either go 45 units clockwise or realize that that's the same thing as if we add 360 to negative 45, we'd be at 315. And we'd be 5 units out, so 1, 2, 3, 4, 5. And then this time our point is going to be at 315, so kind of between the 310 and the 320. There's point C. And our last one, if we change this to a positive 1, again, you can add 180 to this, or subtract. In this case, I'm going to add, and we end up at 1,60 degrees. So 1 unit out, but at that same degree measure as A. There would be point D. Now the same thing can be done for radians. For instance, if we look at the first one, we are at 3 and then pi over 3. So we're going to go out 1, 2, 3 to get point A. Point B then is going to be, again, a negative that I sometimes would like to just change back to dealing with a positive. So again, I can add 1 pi to 5 pi over 6, and it's the same thing as saying 11 pi over 6. So again, that negative kind of flips it from being at 5 pi over 6 to 180 or 1 pi, half the circle beyond. So at 11 pi over 6, we would be 2 units out. This is point B. Point C then, either again, negative pi over 4, or if we add 2 pi to that, that's the same thing as saying 7 pi over 4. So that's going to put us out 1, 2, 3, 4, right here. And then last but not least, point D, again, I like to change this negative R to a positive by adding pi, or subtracting again, and I'm going to add this time since it's a negative. If I add 1 pi to negative 2 pi over 3, I get positive 1 pi over 3. And again, we're going to be 3 units at 1, 2, 3 units out on that. So that we actually end up at this exact same point that we had before. And that's going to also be point D. All right, so thanks everyone for watching. We'll work more with our plotting in class.